Hello everyone, this video is about indefinite and definite integral. Previously in differentiation, we know that when we differentiate x to the power of 7, we get 7x to the power of 6. When we differentiate x to the power of 7 plus 5, we also get 7x to the power of 6. The derivative of 7x to the power of 7 minus 11 is also 7x to the power of 6. So when we integrate 7x to the power of 6, what do we get? Is it x to the power of 7, x to the power of 7 plus 5, or x to the power of 7 plus 11 minus 11, or maybe something else? So actually there are infinitely many possible integrals. So that's why we have to use the constant of integration c in indefinite integrations. So what do we mean by indefinite? So indefinite basically means there is no number here and here. So there is no limits of integration. The integral of y prime dx is y plus c. So now whenever we're doing indefinite integrations, we have to add the c. So how do we find the c? Well, by plugging in some values of x and y. So for example, given y prime is 7x to the power of 6, and when x equals 1, y equals minus 10, find y in terms of x. So y is the integral of y prime. The y prime is 7x to the power of 6. The integral is, as usual, division line. Rewrite the 7 and the x. The new power is 6 plus 1. Divide by that new power. So we get 7 over 7 is 1. So just x to the power of 7 plus c. Now, since when the x is 1, the y is minus 10, we plug in x and y values, we get the value of c, which is minus 11. So, in conclusion, the y equals x to the power of 7 minus 11. Another example, a curve y equals f of x passing through the origin has a gradient function of f prime of x equals 3 over 2 square root 3x plus 4. Find the value of y when x equals 7. So to find the y or the f of x, we integrate the y prime or the f prime. The integral of this expression is the same as, well, this is the same as 3 over 2 3x plus 4 to the power of minus 1/2, because square root and it's in the denominator. And now we use division line, rewrite everything. The new power is 1/2, divide by the new power, divide by 3 as well from here, and after simplifying everything, we get the square root of 3x plus 4 plus c. Now this phrase passing through the origin means when the x is 0, the y is 0. So this means we can just replace this x with 0 and this y with 0, and we can find the value of c. Now that we know the value of c, we know the function, and after we know the function, we can find the value of y when the x is replaced by 7 and it's 3. In definite integration, so we were doing indefinite, now we're doing definite integration, where we have these limits of integration numbers up here and down here. So we just integrate as usual. We don't use c, and we plug in the upper limit first and then the lower limit, and then we subtract. So for example, the integral from 3 to 6 of x squared dx, the integral is, as usual, division line. The new power is 3 divided by 3, so x cubed over 3, and then we plug in 6, so we replace the x with 6, we replace the x with 3, and subtract, use a calculator, and we get the number. Now in another example here, we have 2x plus 3 all squared divided by x to the power of 5. This seems complicated. Remember, we cannot simply integrate the numerator and then the integrated denominator separately. So we can start by expanding the numerator, and you see here it's a fraction. We can split the fraction. 4x squared divided by x to the power of 5, 12x divided by x to the power of 5, 9 divided by x to the power of 5. So here we can simplify. We get 4x to the power of minus 3 12x to the power of minus 4, and 9 5 to the power x to the power of minus 5. So we can integrate now 4x to the power of minus 2 over minus 2, 12x to the power of minus 3 over minus 3, 9x to the power of minus 4 over minus 4, and then we replace the x with 2, we replace the x with 1, and then subtract. Use a calculator. Simple improper integration means, yeah, well, it involves infinity. When we're dealing with infinity, we call it simple improper integration. So we integrate as usual, and then just remember 1 over infinity is 0, or anything over infinity is 0. So this is the same as minus 7x to the power of minus 2, and when we integrate, we get minus 7x to the power of minus 1 over minus 1. The minus cancel out. We have 7x to the power of minus 1, which is 7 over x. We plug in the infinity first, and then the 1, and then we subtract. Anything over infinity is 0, so it's just minus 7. That's it. I'll see you again next time.